On the third page, we're going to use logarithmic equations in story problems. The first question says the average number of free throws a basketball player can make consecutively during practice is modeled by this function, where x is the number of consecutive days the player has practiced for 1 hour and y is the number of free throws they have made in a row. We must use this formula to find how many days of practice x it will take a player to make an average of 7 consecutive free throws. The first thing we must do is figure out what the 7 needs to be plugged in for. Because we are talking about consecutive free throws made, that is going to be plugged in for my y. So the first thing I'm going to do is put 7 in for y. Now I must use my logarithmic properties to solve this. The first thing I'm going to do is subtract the 1 from both sides. So if I subtract 1 from both sides, I'm left with 6 equals 1.3 ln of x plus 1. Before I can do anything else, I must rewrite that function with 1.3 as a power, or I can get rid of the 1.3 by dividing, which in this case would probably be easier. So if I divide 1.3 on both sides, I'm left with 4.62 equals ln of x plus 1. Once you have it written like that, we can then rewrite it into exponential form. If you remember, ln is just base e. So my base here is e, so when I rewrite it, it becomes e to the 4.62 equals x plus 1. From there, I can punch out what e to the 4.62 equals, and once I get that number, I have 101.49 equals x plus 1. Then all I have to do is subtract the 1 and make that 100.5 hours. And that is how long it will take. Now, if we had to round this to the nearest whole day, it would be nearest hour. It would be approximately 100 hours. To get the number of days, we would then divide that by 24, assuming that they're doing it 24 hours a day, and it would be approximately 4 days. For the next problem, we are using Newton's law of cooling. And this states that for a cooling substance with an initial temperature T sub 0, the final temperature T sub F after T minutes can be modeled by this equation, where T sub R is the surrounding room temperature and R is the cooling rate. Lots of variables in this problem. So we are cooking an Ethiopian stew. When you take it off the stove, its temperature is 212 degrees. The room temperature is 70 degrees, and the cooling rate of the stew is R equal to 0.046. It sits on the counter for 34 minutes. Ideally, to eat the stew, you want it to be below 100. What would be the final temperature of the stew? Did you let it sit long enough? All right, so what we have to do is we have to figure out the final temperature. So we're going to try and figure out T sub F. If you look at T sub 0 was my initial temperature. So when we took the stew off the stove, that initial temperature was 212. The T sub R represents the surrounding room temperature. They tell us in this problem that the room temperature is 70. E stays E. They tell us that the rate is 0.046, so this becomes negative 0.046. My time, it was sitting there for 34 minutes, so that's times 34. And then I have to then again add my plus 70 at the end. When I punch this all on my calculator exactly as it's written, my final temperature is 99.72 degrees. So if I wanted it to be below 100 degrees, did it sit long enough? Yes, it did. So my answer would be yes, my final temperature was 99.72. On our last problem, we are using the same equation again. Your parents buy juice for your graduation party and leave it in their hot car. When they take the cans out of the car and move them to the basement, the initial temperature of the juice is 80 degrees. The room temperature of the basement is 60, and the cooling rate of the juice is R equals 0.0147. A good serving temperature for juice is 63 degrees. How long will it take to cool to 63 degrees? So this time they give us the final temperature, and we have to find how long or the time. So I'm going to plug in 63 for T sub F. My initial temperature was 80. and the surrounding temperature of the basement was 60. My rate was 0.0147. I do not know my time, but again, my surrounding, my T sub r, my surrounding temperature was again 60. What we have to do is we have to solve this problem. So I'm going to kind of do two steps in one. The first thing I'm going to do is subtract 60 from both sides and get 3. At the same time, I'm going to combine the 80 minus 60 and get 20. Once I do this, I'm then going to divide by the 20 to get 0.15. And now we have to solve this equation. If you recall in the past, this is written in exponential. We can always go back and write it in logarithmic. So in order to have a base of e, I use ln. That base is e right here. What it equals, as my power here always goes on this side, and this number right there pops in there. So this and this are the exact same thing, just written in two different forms, one in exponential and one in logarithmic. Now I can punch out ln of 0.15 on my calculator. And when I do that, I get negative 1.897 equals negative 0.0147t. And then once I do that, I can then just divide by the negative 0.0147, and my final answer will be 129.1 minutes.